minutes we are about to begin. This event is brought to you by the College of Engineering Student Council of Technological University of the Philippines in cooperation with Let's Learn Incorporated.
Kindly use the chat box for your questions and clarifications later. Or you may use the virtual heart reactor for you to be recognized and for you to open your mic. For now, kindly mute our mic to give way to our today's speakers. We will start after a few minutes. Thank you.
Labutong, on behalf of College of Engineering Council, entitled Real Life Application of Mathematics and
I am Laura Jane Labutong, your moderator for today. This event is brought to you by the College of Engineering Student Council in participation of Mechanical Engineering TIP Manila, Civil Engineering TIP Manila, Mechanical Engineering FEU, Electrical Engineering TIP Manila, UPs, UPSES, OSS TUP, and PSME TUP.
we would like to extend a very warm welcome to everyone in this webinar. We appreciate all of you for or comment, let's learn on the chat box if you are now ready. We hope that you will learn a lot from our guest speakers. But before we start our program, let us ask guidance to our Almighty Father and followed by the national anthem.
Let's put ourselves in the presence of the Lord. Dear Father, we offer everything and thank you for everyone gathered here today to walk with you. May we ask you for your blessing and guidance so that the activities set for this undertaking be successful. We ask you to open our eyes to see the wonderful things from this activity. We ask that you to open our ears so that we may retain the invaluable knowledge. Open our minds for us to think wisely. Fill us with understanding, cooperation, and peace in fulfilling our responsibilities. Open our hearts so that we may receive your everlasting love. And open our spirit so that we may know that you are with us all throughout the day. We ask all this in the name of Jesus Christ. Amen. For our opening remarks, we will proceed with the national anthem.
Mga kababayan, ang pambansang awit ng Pilipinas. Tayang magiliw, kalas ng silanganan, alam ng puso, sa dikit mo'y buhay. Lupang hinirang, kuya ka ng magiting, sa manlulupin, di ka pasisikin, sa nagatak tutok sa simoy at sa langit mong pangkaw, ay ginatang tulad, awit sa paglayang minamahal. Ang isang ng matawad mo'y tagumpay na naghihiling, ang bituin at araw niya kailan pa may di magtitingin. Lumalang araw ng walhaging pagsinta, buhay langit sa piling mo. Ang inigaya na pagkay pag-aami, at mamatay ng dahil sa'yo.
For our opening remarks, we are pleased to have the diligent Vice Governor of Student Council of College of Engineering. She is currently a third-year civil engineering student. I present to you Miss Joy G. Acuin.
Good day, engineers and future engineers. I am Joy Akuin, the Interim Vice Governor of the College of Engineering, TUP Manila. Welcome to the webinar for engineering students with the topic Real-Life Applications of Mathematics and Physics in cooperation with the Let's Learn Incorporated. And of course, with the participation of the following.
For us to get more work out today and uplift our spirits, the next person transformed many students' lives in the field of engineering.
Indeed, he is a former director of Philippine Association of Engineering Schools, or PAES, currently senior accreditor of Accrediting Agency of Chartered Colleges and University in the Philippines Incorporation, or AACCUP. To share his insights and inspiration, we call on the Dean of the College of Engineering of Technological University of the Philippines, Manila. Let's us big virtual hand of applause to Engineer Benedicto and Fortaleza.
Hello, good afternoon. Can you hear me?
Yes, sir, we can hear you po.
Okay. Thank you very much. To our guest lecturers this afternoon, to the organizer of this event, particularly the student government of the College of Engineering, headed by Ronel, RJ Handusay, and Miss Joy Akuin, and mga kasama niya. Okay? To the faculty from the College of Engineering, of course, with Sir Nilo, and to the organizers, no? Yung ating two-piece, USS, TOPSES, and TUPPSNE. And of course, with the cooperation of the different organizations from different schools. I understand we have here TIP and Far Eastern University. Thank you for joining. We are lucky this afternoon because two or how many of them will be sharing their talents when it comes to mathematics and physics. I am very happy that we have with us Engineer Tim Amado, one of the best fellows of PUP. And of course, yung kanyang kapatid, si Kulin sa side naman ng physics, at siyempre sa kasama nila sa Let's Learn. Thank you very much for this effort. Timely talaga kasi nasa pandemic tayo, hindi tayo makapag face-to-face seminar. Tapos ginawa nyo ng paraan para dito sa webinar na ito. I hope marami ang makaka-attend dito. Thank you sa mga organizers nito. Okay? Talagang nag-efforts kayo para sa ating mga kabataan. Oo. This is very important. Mathematics and physics and application to real life of these two subjects is very important. No? Napaka mahalaga, napaka exciting. No? And with our speakers for this afternoon, talagang talagang ma-appreciate nyo. At hindi basta-basta ang ating mga speakers, no? Pareho silang magna cum laude. Okay? Kaya I am very proud of these guys. Thank you for sharing your talents, no? Na walang kapalit, walang alam mo 'yun. So this is something great. And we have to appreciate this. Okay? So I hope tatapusin niyo yung yung program natin, at kung may kasunod pa ito, much better. Malaking tulong sa atin bilang nag-aaral ng engineering. Ito ay hindi rin basta lang. This is included in the board exam, mathematics and general engineering sciences, where physics is included. Makakatulong sa atin ito sa board examination na ating tatahakin pagdating ng araw. That is 2 years or 3 years from now, kukuha kayo ng board exam. At makakatulong sa atin ito ng malaki. So, please stay with us. Please stay with the group hanggang ilang oras ito, 2 or 3. At marami tayong kapupulutan dito. Thank you very much for inviting me to this event. Thank you and good afternoon.
Thank you, Engineer Benedicto, for that encouraging and warming words from you. Again, thank you.
We are all geared up for today's event. We would like to recognize and acknowledge our exemplary guest speaker, an astounding Assistant Professor 2 of the Electronics Engineering Department of Technological University of the Philippines, Manila, whose expertise ranges from data analytics, artificial intelligence, deep neural networks, and computational analysis. One of his many research publications is Machine Learning Predictive Models for Improved Acoustic Disdrometer at 2018 IEEE Fent International Conference, a magna cum laude in Bachelor of Science in Electronics Engineering at TUP Manila. Took his master's degree at Mapua University, and he is currently taking a doctorate degree at Mapua University. I am proud to present to you Engineer Timothy M. Amado from Let's Learn Incorporated.
Ano mag- Hi guys. Ay, tag dito. Game na ba?
Yes, sir. Okay na po. Rinig naman po kayo.
Sabi kami ni Colin eh.
That's a... Okay.
To the foreign exam speaker. In both physics and mathematics. experienced coach from physics quiz. One of her publications in the proceeding of the International Conference on Future of Education at 2019 is the Student Engagement of Gamified Physics course. She is also a consistent honorable student. Magna cum laude in Bachelor of Secondary Education, major in physics at Philippine University of the Philippines. Took her master degree at De La Salle University, Manila, and she is currently taking her doctorate at the same university, which is De La Salle University, Manila. She is also a professor in mathematics and physical science at Technological University of the Philippines. Let us welcome Professor Colleen M. Amado from Let's Learn Incorporated.
Good afternoon, everyone.
Good afternoon, Professor
Good
Colleen.
afternoon po.
So, shall we start?
Disable pa yung share screen ko. Okay, no? So, what's up guys? So, welcome no sa ating webinar for today. So, for a moment lang guys, no, because I'll be sharing the PowerPoint presentation for today's webinar, no. Medyo may konting technical error lang because I think I can't share yet, no. Mhm. For a moment lang guys, Mm. Aha. Wait lang. All right. So, ayan, no? Yan. So anyway, so habang inaayos natin yung konting technical difficulty, no? Kasi yan, I would like to take this opportunity na magpasalamat sa lahat, no, for attending this webinar. So indeed, this is very timely, no? Lalo-lalo na ngayon na nasa ano tayo, no? Nasa stage ng shifting natin, no, from physical face-to-face classes papunta sa online classes, no? So I think most of you, or maybe some of you, no, are not really that motivated, no, to study during these times, no. So that's why, no, this webinar is brought to you, no, by Let's Learn Incorporated in partnership with the College of Engineering Student Council, para kahit papaano, no, we will be ano, no, para kahit papaano mapamilya, alam mo yun, malaman natin yung iba't ibang mga real life applications na mga pinag-aaralan natin sa math and physics. 'Di ba? Ano, tama ba, Ma'am Colleen?
Yes, tama ka dyan, Sir Team. So, I think, no, based, kung nabanggit nga natin na ang aking mga research ay may kinalaman sa student engagement. So, I'm very familiar, no, as to how engagement or interest motivation affects how students learn. Okay, so I think talagang makakatulong sa kanila to para to ano naman to appreciate, no, and be willing or be excited to learn math and physics.
All right, no? So, ayan. So, okay na, no? So, nasi-share na natin ang ating screen, no? So, again, I would like to welcome everyone in our today's webinar entitled Real Life Applications of Math and Physics. No? So, again, I'm Sir Tim, no? And my sister, Ma'am Colleen, no? Kami ang Prankster Brothers.
Is a prank. Joke lang po. Joke lang po.
Ayan, no? So, ayan. So, kami ang magpa-prank, no? Hindi, joke lang. Okay, so, game. Shall we start? Game! Let's do this. Okay, nice, good. Nice, good. Okay. So, okay. So, we're gonna start our talk, no, with this common na saying, no, na math and physics is hard. Tama? Yes, no? Even us, no,
no? Siya lang ang kausap ng kanyang professor. Okay, so that happens also in both physics and math. And lastly, okay, so nakikita na natin ang frustration dito ni Miss, no, or si ating student. She's already biting the pencil, no, which means that yung tinititigan niya sa screen is really really hard, no, for her, and cryptic. Okay.
Alright, no? So, ayan guys, no? So, yun yung parang pinaka-common na naiisip natin when we think about math and physics. Math and physics is hard. Okay? And also, no, this saying na laging, laging madalas nating maririnig, no? Parang kadalasan ito yung mga, kumbaga, sentiments and rants, no, ng mga students when it comes to math and physics. So, sabi daw nila, no? Ito ang madalas nating makikita sa kanila. Ano ba yung math and physics na yan? Di naman magagamit yan sa tunay na buhay, pampahirap lang yan. So madalas yan ang naririnig natin, no. Sabi nila na hindi naman magagamit sa tunay na buhay, wala namang application. Madalas may mga jokes pa nga and may mga memes, no, about mathematics and physics being literally useless, no, in real life. Okay? So ayan ang yan ang naging motivation ng Let's Learn, no, para sa webinar na ito, no. So ang webinar na ito ay para mapagbigay alam sa inyo na hindi naman hindi naman totally useless, no, ang math and physics in real life. And it is our dream as well na kapag nalaman na ng mga students, no, ano ba yung importance ng mathematics and physics in real life, ay matutulungan nila tayo na magkaroon ng motivation, no, and interest towards learning. So Ma'am Colleen, 'di ba part ng research mo as an educator, no? So by the way, Ma'am Colleen is the educator, no, pagdating sa sa Let's Learn Incorporated. Ano ba ang kinalaman ng motivation, no, and interest, no, when it comes to driving students, no, in terms of learning?
Okay, so yun nga, no, so sa dami kong nabasa ng mga literature about motivation, engagement. So it's really one of the factors, no, very important factors that nakaka-affect, no, as to how students perform or yung student achievement when it comes to different subjects, no, not only math and physics. Okay, so just like what is said, no, in this statement, no, so they are finding that interest, no, can help us think more clearly, okay, understand more deeply, and remember more accurately, no, so which alam natin is very important for students, no, for them to understand, no, to really learn the subject. So interest has the power to transform struggling performers, and hindi lang to para sa mga struggling performers, no, to lift high achievers to a new plane, no. So on the part of those who are struggling with the subject, so it helps them, no, to students. So I think, no, regardless of the age, so we still have to come up with a way, no, as to how we can develop or enhance the interest, motivation of our students, so as for them to perform well in our subject, specifically for math and physics.
Okay, no? So, thank you with that, ma'am, no, for sharing your expertise towards understanding how interest, no? So, kapag interested ang isang student, no, we believe that yung pagtingin niya sa isang subject will be different. So that's why, guys, no, we're going to share to you, no, today. Okay, so bali parang pinaka-seminar natin or webinar natin today is basically 8. Okay, 8 real-life applications of math and physics. Okay, no? So naniniwala kami.
Sir, bakit 8? Bakit ba 8 ang natin, ang ipe-present natin? Parang di ba? Parang alanganin, dapat 5 or 10. Bakit 8 ang napili natin i-share?
Oo nga, no? Oo nga, no? So, bakit nga pala 8, no? So, 8, kasi if you still remember, 8 is, a good number, a stable number, a perfect number, actually, no? Pagdating sa chemistry, di ba? Sa bonding, di ba? Chemical bonding, pinaka-stable yung 8 na number. Tsaka, para hindi masyadong matagal matapos ang webinar natin. Okay?
Okay. Parang mas maganda yung pangalawang dahilan. Okay, sige.
Alright, no? So anyway, here we present, guys, no, the 8 real-life applications of math and physics. So just sit back and enjoy, no, as you witness, no, saan ba ginagamit ang math and physics in real life. Game, let's do this. Okay, nice, good, nice, good. All right, so number 8, no? So we have matrices. Ayan, no? So saan ba tawag dito? Matrices, no? Alam naman natin yung mga matrix, guys, no? So matrices is basically just an array of numbers, no? So parang this is a 2D array of numbers, no? So pwede naman hindi numbers, but most of the time sa matrix ang nalalagay natin ay mga numbers, no? So like we have here a 3x3 matrix, no? So 1 2 3 4 5 6 7 8 9. So pinag-aaralan natin 'yan, guys, no, sa ating mga sa ating mga courses, no, sa ating coursework, included ang matrix, no. So sa ibang discipline, I'm not really sure kung what point pinag-aaralan, pero sa ECE we studied that, 'di ba, sa ating advanced math. Okay? Especially sa ating advanced math laboratory, pinag-aaralan natin ang matrix. I think it's also included in advanced algebra. Okay? Especially sa ating advanced math laboratory. I don't know if pinag-aaralan natin advanced algebra pa ba, no? Kasi syempre, yan, medyo matanda na tayo, hindi na natin memorize ang curriculum. Pero nung bata pa ako, no, it's included in the advanced algebra. So, pinag-aaralan natin, meron tayong mga operations sa matrix, 'di ba? Kung ano yung mga pinagagawa natin. Okay, no? So, yung matrix natin can be as large as 1,000 entries, no? So malaki ang matrices natin, no? Pwede rin 'yan na magkaganyan. Okay? So now, guys, no, what I'm curious about actually is ano ba ang gamit niyan in real life, no? So actually matrices, it's one of the foundation of a subject called linear algebra. Okay? So, isang buong subject ang dedicated sa pag-aaral ng matrices dahil marami siyang applications. But I think the one that we can really relate into is, okay, ano ba yan? Images. Okay? So, matrices ay gamit na gamit when it comes to images. Okay? So, bakit kaya, no? Anong kinalaman ng matrix, sir, no, sa image? Okay. So, before understanding how matrices are related to images, let's talk about pixel. So ano ba ang pixel, guys? So pixel, or picture element for short, is the smallest element that makes up an image. So I have here an image or a picture of Gyarados, no, red Gyarados, no. So people who played Pokemon Gold, no? So kung naaalala niyo si Gyarados, no, na pwede niyo siyang mahuli, isang red Gyarados, shiny, no? Gyarados. Okay, so makikita natin dito, guys, no, na this is what we call a pixel art. Okay, para ayun yung pinili ko para maintindihan niyo talaga yung pixel. So yung pixel is in the smallest element na meron. Okay? So kung makikita niyo yung mga resolution, guys, no? So the higher the resolution, okay, the mas marami yung number of pixels in an image. So here, kuha tayo ng isang box. So ito yung isang box doon, no? So may kulay siya na reddish something. So itong kulay na to actually is formed by combination of different colors, no? So it's a combination of red, green, tsaka blue. So in this case, itong picture na to, or itong color na to is 192 red, 13 na green, tsaka 11 na blue. Okay? So, ibig sabihin pala, guys, no, itong ating buong picture na to can be represented as numbers, taking one pixel as three numbers. Right? Like, this square na maliit na to, yung number niya ay 192, 13, tsaka 11. So, basically, no, ito ay tatlong matrices, okay, combined together. So, meron tayong isang matrix na siya yung magbibigay ng red color, isang matrix na magbibigay ng green color, at isang matrix na magbibigay ng blue color. So basically, the images is actually matrices, no, from the background, no, from the other perspective, no. So yung mga images natin is composed of matrices. So ano naman ngayon kung they are composed of matrices? Okay? Because they are composed of matrices, no, there are numbers, we can perform operations to them, and that is the birth of image processing. Okay? So kung hindi gawa sa matrix, no, ang mga images natin, hindi magkakaroon ng image processing. Image processing is an area sa computer science as well as electronics engineering as well, no? Kung saan no we do different mathematical operations doon sa mga matrices natin para ma-correct natin yung image. Like for instance, no, in this example, meron tayong blurred image. So gagamit lang tayo ng averaging, no, median filter. Okay, so we can use median filter para yung mga numbers, okay, maayos natin to be able to have a reconstructed image na walang blurring, no? So, yun ang ginagamit natin sa blur correction. Okay? So we can also use histogram equalization, no? Kasi syempre may histogram because numbers yan, we can have an histogram, and because of that histogram, we can actually spread it out para maging even yung lighting in a certain image. Okay? So, yan yung mga examples ng image processing, no? So, this is also an example kung saan pwede nating gamitin ang image processing because the image is made up of matrices. Okay? So, here's one of the research that I did before. Okay? So, ito ang ginagawa dito is binibilang natin yung yung red blood cells sa isang blood sample. The idea kasi guys, alam nyo ba na to count the number of red blood cells, kinakount talaga siya manually nung mga binibilang yan manually nung mga medical technologies. Okay? So bali ang ginagawa nila is kumukuha sila ng certain square dito, binibilang nila, tapos minumultiply nila sa area. Parang density ang mangyayari. Okay? So what we did in this research project is we have an image. Ito, yung A kasi is galing do sa original image. Ito yung nag-apply tayo ng sharpening, nag-apply tayo ng grayscaling, and nag-apply tayo ng some image reconstruction. Okay? Image processing techniques. Tapos, okay, nag-apply tayo ng mga image analysis techniques para ma-separate natin yung mga cells at then, nabilang na natin siya. Okay? So, nakita nyo guys, because of mathematics, because of understanding matrices, we are able to make technology, okay, na something like that. Na from manual counting of medical technologies, nakagawa tayo ng technology na nabibilang na natin ang red blood cells automatically. Okay? So, konti lang yan sa ibang mga example. Talking about image processing is like a whole another webinar. But again, utang natin ang image processing because digital images is made of matrices. Okay? So kapag mag-aaral uli kayo ng matrices, no, lagi niyong iisipin na hindi to useless at hindi to walang kwenta, nagagamit to sa magandang bagay. Yes? Yes, no? So, nice, good. Okay. So, any additional thoughts, Ma'am Colleen, about matrices? Napag-aralan nyo ba yan sa physics, yung matrices?
Oo, ina-apply namin yan sa mga na din, most of the time sa mga higher level physics na yung mga inaral ko nung master's tsaka ngayong PhD. Okay, so I'm actually amazed, no? So, yan pala, no, ang application napaka-importante pala ng application ng matrices, no? Kasi lahat tayo mahilig sa picture, ganyan. So, talagang may kinalaman pala siya sa buhay natin, no? It turns out. Okay, hindi lang siya another difficult topic in mathematics.
Okay, so that's great, no? And I hope na kahit papaano yun, no, na natutunan ng ating mga students na yan, pwede nyo rin i-share, no, na ang matrices pala ay nagagamit sa image processing. Okay, so yeah, so that's again, this is 8 real life applications of math and physics. Okay, so for number 7, no? So number 7 application, we have Newton's law of cooling. Okay? So this is under the topic of differential equations, no? So sa mga student ko dyan, no, ng differential equation, no? So I think na-discuss na natin itong Newton's law of cooling. So para saan ba siya, no, ginagamit? One of the applications niya. Okay. So, when we are still young, okay, kami ng sister ko, we're really fond of watching this show, no? So, naalala niyo ba tong show na to? Di ko alam kung inabot to ng generation niyo, no? But when we are young, no, just like you, paborito namin to nung kapatid ko, no? So, ito yung palabas. Ano bang title ng show na to, ma'am?
Detective Conan. Tama ba? Tama ba ang title? Ano ba yun? May Japanese, Japanese translation. Okay. Yun, Detective.
Okay, so Detective Conan or Case Closed, no? Yan yung Japanese title niya.
Tama,
Japanese
hindi,
pero English.
tama, hindi ko alam. Japanese pero English. Tama, hindi ko alam yun. Alam ko lang Detective Conan. Yun ang pinapakita sa TV. Okay.
So Detective Conan ano siya no sa si ano no sa si Shinichi. Okay, Shinichi Kudo no. So isa siyang young detective no. Ay siya isang teenager detective. Kaya lang parang nahuli siya ng isang organization tapos pinaliit siya. Kaya naging bata siya. Okay, so ganun si ano no si Detective Conan, okay? Tapos bali parang may nag-ampon sa kanya. Ayan si ano no si Kogoro Mori no. So isa siyang private detective no si Kogoro Mori. So sumikat si Kogoro Mori kasi ano no, tuwing may isa-solve siyang kaso, okay, ang ginagawa ni Conan, kasi magaling si Conan eh. Si Shinichi Kudo na lumiit, Conan na yung pangalan niya. So pinapatulog niya si Kogoro Mori. Tapos siya yung nagde-deduce ng mga ano no, siya yung nagde-deduce ng mga kaso no, mga murder. Usually ang mga kaso na dinidiscuss dito. Okay, by deductions of Detective Conan through Kogoro Mori. No? So pinapatulog niya. Kaya sikat to no, si Sleeping Kogoro. Okay? So one thing that fascinates me before is the estimation of the time of death. Ayan, no? Wala namang mga laboratory na nandun. Okay, nandun lang sila no in a certain room. Okay, wala pa mga laboratory test na ginagawa pero na-estimate nila no yung time of death nung mga ano no, yung yung mga namatay doon sa ano na yon, sa show na yon. Okay? So actually no, paano ba talaga ginagawa yon? Talaga bang hinuhulaan lang nila o may something mathematically behind of estimation of time of death? So the idea there guys is the Newton's law of cooling. Okay? So ano ba yung Newton's law of cooling? Sabi dito no, it states that the rate of heat loss of a body is directly proportional to the difference in temperatures within the body and its surroundings. Okay? So ito yung parang ano niya, mathematical model niya guys, no? So we'll not be solving differential equations today, no? Papakita lang natin paano natin magagamit ang Newton's law of cooling pag-estimate ng time of death. Okay? So sikat na sikat to guys, no? I don't know if you played this one. So ito yung isa sa mga sikat na laro ngayon, no? It's called Among Us. Ayan, no? So yan ang example ng character natin na si Green, no? Siya si Green. So si Green guys, no? So nandun sila sa ano no, sa room, okay? Sa isang, 'di ba, parang spaceship 'yon. Okay? Yung temperature ng body, okay, pag buhay pa tayo is 37 degrees Celsius. Assuming na wala tayong lagnat. Approximately 37 degrees Celsius. Tapos, for instance, yung room is 20 degrees Celsius. Tama? Okay. So ngayon, dun sa game na Among Us, di ba, may impostor. Ang ginagawa ng impostor, ayan, no? So, they, ano, no? They kill, no? Yung, ano, no? Ayan. So, ayan, for example, no? Kinil ni Black si, ano, no? Okay, si Green. So, ang mangyayari, ayan, so deads na siya, di ba? Ayan, ganyan yan sa game natin. So, deads na siya. Ngayon, dahil patay na si Green, okay, meaning to say the temperature of the body remains the same even if the temperature of the surrounding is different from the body. Okay, so yun yung characteristic ng 'di ba, ng mga warm-blooded, no? So unlike yung mga isda, yung mga reptile, ginagaya nila yung temperature ng surroundings nila. So tayo hindi. Mine-maintain natin na 37 degrees Celsius. Kahit na 20 degrees Celsius yung room temperature. Pero pag patay na tayo, anong mangyayari? So ang mangyayari guys is bababa yung temperature ng katawan natin until such time na lumapit na siya or maabot niya na yung temperature ng room. Okay? So with this, no, we can actually estimate the time of death. So we just count the number of hours and then check the temperature. Use the mathematical model and we can actually trace back no yung approximate na time of death. Okay? And with that, no, pag alam na natin yung time of death, pwede nating mahuli ang impostor. Okay? So ayan ang application no ng Newton's law of cooling. So it can be used to approximate the time of death or estimate the time of death. So isa siya yan. So sa mga ano no mahilig sa mga ano no, mga forensic shows no. So isa 'yun sa mga idea na ginagamit. Okay? But of course no, so syempre mas reliable pa rin na meron tayong mga laboratory tests like yung mga rigor mortis na test. But this one dun isa sa mga gamit nun ng Newton's law of cooling. Okay? So, ayos ba? Nice, good? Nice, good. Okay. Ano, so now, okay, no?
Okay. Sige. So next. Punta naman tayo sa mga sa mga buhay. Okay, yung pinag-usapan natin nakaraan ay patay na, no, and then how to determine the time of death. So punta naman tayo ngayon sa mga buhay and how to prevent, no, or how to keep people safe. Okay, so application tayo ng momentum and impulse and Newton's laws of motion. Okay. Sige. So, a philosopher once. Hindi, okay. So, mahilig tayo sa quotes, no? Okay, so according to Douglas Adams, no? So, it's not the fall that kills you, rather, it's the sudden stop at the end. So, ano kayang ibig sabihin niya doon, no? So, it's not the fall that kills you. Cryptic, no? And it's the sudden stop at the end. Okay, so this can be explained by the impulse momentum theorem, no, in physics. So according to this impulse momentum theorem, no, so the change in momentum of an object equals the impulse applied on it. Okay, so in equation, and nakikita natin. So delta P equals I. So where I, sometimes J yung ginagamit, no, is the impulse, and then delta P is the change in momentum. So most of the time, ang nagbabago is yung velocity, hindi naman nagbabago yung mass, no? So kaya ang change in momentum ay attributed sa change in velocity. And then yung ating impulse, diba, ang impulse is the force applied na over certain period of time. Okay, so ano ibig sabihin ng it's not the fall that kills you, it's the sudden stop at the end. So meron niyang kinalaman sa time, no, amount of time that the force is acting on the person or on the object. Sige po. Ayan. So for the same impulse, if the time is shorter, the force is larger, no? Di ba? Equal yung impulse. Ano ba? Pareho yung nangyari. For instance, an object that is that fell, no, from a building, no? So pareho dalawang scenario, parehong dalawang object, same object fell from the building. So same yung change in momentum, no? Di ba? Kasi they came from the same height. So ibig sabihin the impulse is also the same, no? So for the same impulse, if the time is short, no? So pag maliit yung time, as you can see dun sa nasa left na equation, no, the force is greater. Now, if the time is longer, so pag malaki yung time, pag mahaba yung time, the impact force is smaller. Okay, so that is why yun yung tinutukoy dyan sa ating expression, ay sa ating quote, no, na it's not the fall that kills you, it's the sudden stop at the end. So pag bigla kang nag-stop, no, if the contact time of the force is if the time of contact is short, the impact force is large. So meaning it would cause more injury. Okay, so let's compare, no, itong isa na nahulog siya directly on the ground, saka yung isa na sasaloy ng net. Okay, so kapag suppose na nanggaling sila sa parehong from the second floor, no, of a building, then they had to jump or they fell, no, from that. So itong isa yung diretso siya sa ground, no, since the ground or the ground or the floor is hard, no, so the time of contact wherein the force is applied would be shorter. So parang gaganon siya, di ba? So, pagka, di ba, na-experience nyo na, pag mabilisan, parang ang lakas ng saltik. Di ba, pagka nang-aaway kayo ng mga gusto nyong manakit, no? So, di ba, pagka isasaltikin mo siya ng parang tela, no? So, kailangan mabilis, no? Para mas masakit, no? Pag mahina, walang dating, no? So, parang ganun din yung nangyayari dito. When you fall directly sa ground, mabilis yung time of contact. So, malakas or malaki yung impact force. Okay, so, therefore, injured ka or much worse, it will lead to death, no? So unlike if you fall on a cushion or on a net, di ba, ano ba nangyayari pag nahulog tayo sa cushion or bumabagsak tayo sa net or sa cushion? Di ba? Anong nangyayari? Dahil malambot siya, no, parang susundan pa niya yung kurba ng body natin, so hindi mabilisan yung contact, no, ng force. Therefore, in that case, the contact time is lengthened and the impact force is lessened, no, or it's smaller. So that's why safe tayo, no, kapag tumalon tayo sa cushion or sa net, no, which prolongs the time of contact. So yung knowledge na yon, no, about this was used, no, or was applied in designing parang safety procedures or safety materials for safety, no, or for example, kapag nagre-rescue, no, yung mga firefighters, no, and hindi na talaga sila makaakyat sa building, for instance, so they will ask, no, the yung nire-rescue nila, the person, no, to just jump off the window, tapos aabangan na lang nila gamit yung net, no? So, kung ikaw yun, matatakot ka, no? Pero yun, given na naaral nila yun, na-applyan nila ng physics yun. So, they designed their safety net in such a way that it will prolong yung force sa'yo, kaya hindi ka ma-i-injure. Okay, so kung alam mo yan, di ba kung napapanood natin sa mga palabas, sir, di ba yung mga tumatakas sa mga humahabol sa kanya, saan sila tumatalon? Ano yung inaabangan nila? Di ba pagka yung mga pinapanood natin sa K-drama, saan sila tumatalon?
Ang naalala ko, nag-aabang sila ng basurahan eh. Ay,
Ayun.
parang truck ng basura.
Oo, yun. Nag-aabang sila ng truck ng basura. Okay, kasi syempre, mga plastic-plastic yun, tapos mga waste material. So, medyo malambot siya ng konti, no? So, it will, yun nga, prolong the time of contact. So, in that way, nakaka-survive sila, no? So, kahit na tumalon sila from a high place. But of course, not too high, no? So, there's a limit, no, to the height of where you can jump off, no, for you to still be safe. So in those cases, no, kapag naharap ka sa mga ganong cases, so probably you could look for an area na medyo may bushes siguro, no, ng plants, or yun nga, anywhere na medyo cushioned, no, or soft, so as to prevent, if not na maging zero injury ka, if to prevent no more injuries or severe injuries. Okay, so ina-apply yan ng ating mga scientists, no, in designing the safety equipments that they use. Sige, some other examples or applications are, okay, ano naman, kapag di ba may instances, no, na nawawalan ng brake, no, yung sasakyan. So paano ka na ngayon? So if possible, we can survive, no, if we'll be able to look for something na, yun nga, medyo soft siya, no, or medyo cushion. So, instead of, pag nagpanik ka na, no, instead of ibabangga mo siya sa wall, so you could probably look for something that's soft. So, in that case, ayan, yung nasa example is parang dayami. Ayan, pero syempre, wala naman tayong dayami anywhere, no? So, probably you could just look for mga halaman, no? So, just to lessen, no, lessen the impact force and lessen the injury. So, instead of nagpanik ka na, no, talagang binunggo mo na lang siya kahit saan. So, sa wall, no, which is hard, no, which will in which the time of contact is very short, no, so malaki yung impact force pagka ganun. So kapag nandyan kayo sa mga ganyan scenario, so try your best, no, to look for something that's cushioned, no, or something that's soft. So ang pinaka common nating makikitang ganyan is yun, kung may pile ng basura or kung may may mga puno or mga halaman, mga bushes, no, so probably you could have that, no. So instead of bumping sa mga matitigas na surfaces, so at least, though may injure ka pa din, for most likely, no, kung talagang hindi ganun ka-soft yung surface, no, but still, it will reduce, no, it will reduce the injuries, no, that you will get from the accident, no, from the scenario. Okay, some other applications is yung airbag. Okay, so, iisip nyo paano nila naisip na lagyan ng airbag yung ating mga kotse, no? So, paano nila naisip na mag-build ng airbag as one of the technologies na part ng mga sasakyan. So, it's also for the same reasons. In the case of accidents or sudden stops, no? Kapag sumubsog ka, so dahil malambot yan, yung mukha mo, no, will be in contact for a long time because it's cushion, no? Because it's soft, no? So, it will lessen the injury, no? Kasi the longer the time, the lesser the impact force. So, yun yung in-apply nilang principle in coming up with this technology, no? Safety equipment or device in our vehicles. And then, lastly, yun. So, yung ating mga helmets, no? So, hindi lang siya para cool ka, no? Or para decoration. So, it's principle is also based on this, no, impulse momentum theorem. So it cushions, no, your head, no, so that in case of yun nga unfortunate circumstances wherein you fall, no, from your bike o kaya nag-fly off ka for some reason, no, so your head will be cushioned, so it will not the contact time will be longer, so the impact force will be shorter. Okay, so tatandaan natin yan. The longer the time, no, the smaller the impact force. So kailan naman applicable yung maliit na contact time and kailan naman siya beneficial, yung maliit na contact time tsaka malaking impact force. Beneficial naman siya kung alam niyo yung mga karate chop, 'di ba? Paano nila ginagawa yung karate chop, sir? Ano dapat? Ano yung sekreto para ma-chop yung mga wood? Dapat?
dapat hihinga ka muna ng malalim.
Tapos, pagkatapos na pag nakahinga ka na,
Pagkahinga mo lang,
hindi. Oy, hindi. Sa karate chop. Paano nila ginagawa yun? Sige.
hinga ka ng malalim, tapos
Tapos, okay. Meron pa ng tunog dapat. Okay. Pero dapat, paano mo siya yung seryoso, yung seryosong sagot. Paano mo siya ipapaluin or i-chop?
dapat mabilis yung
Okay. Dapat mabilis mong isa-strike, no, yung pile of food. So, hindi yun magic, no, hindi sila superhuman, no. So, it's just a matter of shortening, no, the time of contact so that the impact force would be longer, okay? Pero yun nga, na siguro nagiging shorter yung time kapag sumigaw ka ng wacha. Okay, so that's part of it, no? Pero yun, ang sekreto doon is hindi siya magic, no? And they're not muscle man, no? Kahit naman hindi ka muscle man, magagawa mo yun. Basta you have to strike, no, the pile of wood or hollow blocks yata yung iba ginagawa nila, no? With just the right speed, no? So kailangan mabilis siya so that the impact force would be greater and it will break, no, the wood or the hollow blocks, kung ano man yung binibreak mo sa iyong stunt or performance. Okay? Ayan. So yan ang application ng impulse and momentum. I know it's very simple, no, but we don't actually realize, no, bakit ba tayo gumagamit ng mga soft materials. So alam lang natin, safe siya kasi malambot. O bakit nga, no? So that's because of this concept. So ginagamit yan kapag 'di ba sa mga gymnast, yung mga mat nila, no, yung tsaka sa mga baby, yung parang play area ng mga baby, yung parang puzzle, no, na malambot yun. So, kailangan may mga ganon, no, for safety. And the reason behind that is this concept, no. So, impulse momentum theorem. Yan. So, that the longer the time of contact, the smaller the impact force. Okay. Ayan. Sige. Next.
Okay, no? So,
Ay, ako pa pala ulit, no? So, hindi tayo nag-practice. Okay, sige, ako pa pala ulit. So, Newton's laws of motion naman. So, I know you're familiar, no, with Newton's laws of motion and yung mga application niya. So, tingnan natin. First, di ba lahat naman tayo, syempre, sumasakay sa mga, sa mga vehicle, no? So, na-experience nyo na ba na kapag biglang nag-break, anong nangyayari? May mga tumilapon na ba dito kapag nag-break yung sasakyan? Ikaw, sir, na-experience mo na ba yun nung nagbabas tayo dati? Tumilapon ka na ba?
okay, no?
Tumilapon ka na ba?
Oo, kaya...
tumilapon ka na.
Okay, no? So, kwento ko lang, no? When we are still at your age, no? So, nung students pa kami, we ride bus, no? In going to school, no? Ayan, si Ma'am Colleen tsaka ako. Kasi, magkapit-bahay lang na may mga universities namin, di ba? So, I'm a graduate of TUP, tas si Ma'am Colleen sa PNU. So, I still remember, no, when I was in college, no. So, mahilig, feeling ko ako noon no. Feeling ko isa akong ninja, okay, that time. So, anong nangyari noon nung umaandar yung bus tapos papahinto na siya doon sa bahay namin. So, ang ginawa ko, tumalon ako galing sa bus. Ayan. Tumalon ako galing sa jump outside. Oo. So alam niyo na nangyari nung pagtalon ko. Pagtalon ko, anong nangyari? Nagpagulong-gulong ako, gano'n, no? Okay, nagpagulong-gulong ako. Tapos tumayo ako. Tapos, wala na, naglakad na ako. Hindi ko alam kung bakit nagpagulong-gulong ako, diretso na may pagtalon ko. So, ayun, yun ang kwento ko, no? Wala, share ko lang, guys, no?
Okay. Ayan. So, meron tayong mga nakakatawang experiences, no? Alam ko kahit ayaw nyo i-share, no? Yung mga dark secrets nyo. Halimbawa, okay, sa sa jeep, no, halimbawa nag-break bigla si Manong, no. So lahat ng pasahero, no, punta kay Manong. Okay? So lahat tayo na swipe, no, papunta kay Manong. So bakit ba nangyayari 'yon? So the principle behind that is yung law of inertia, no, so Newton's first law. So a body at rest remains at rest and a body in motion remains in motion, no, unless acted upon by an unbalanced force. So ano yung mga sinasabi mo diyan, ma'am? Okay. So kapag initially at rest ka, you will tend to stay at rest. No, kahit na as long as hindi ka ina-apply ng force, no? And then kapag in motion ka, ang tendency mo is to continue moving, no? Unless na anuhan ka, no? Applyan ka ng force. Okay, so yun yung nangyayari kapag ka nagbe-brake, halimbawa, no? So the car is initially moving, no? Tapos syempre gumagalaw ka din, no? You're there with the car, no? Kaso pag biglang nag-brake, no? So yung body mo kasi ay, 'di ba, yung upper body mo hindi siya naka-attach sa bus, no? So, kumbaga pag nag-stop yung bus lang yung nag-stop, no? Walang in-apply na force dun sa iyong upper body. So, your tendency is still to continue moving, no? Kaya pasubsub ka kahit nag-stop na siya, okay? So, kasi your body is still in motion, hindi pa siya nakaka-move on, okay? So, hindi pa siya naapektuhan ng pag-stop ng bus, no? Kasi hindi naman siya connected dun sa bus. Ang connected lang is your puwet, no, and your paa, no, sila lang yung nakadikit sa bus. Pero yung upper body mo, hindi sila nakadikit sa bus. So, kapag nag-stop, hindi ka na-apply ng force, tutuloy ka pa din gumalaw. So, ganyan naman din yung nangyayari kapag galing ka sa pagkakahinto and then aandar yung bus, di ba? Parang sa LRT, parang naiiwan kang pag no? So, ang nangyayari naman is you are initially at rest. So, hindi ka na-applyan ng force kasi ang nakadikit lang sa LRT is yung paa mo, di ba? Di ba? Paa lang yung as in contact, no, with the LRT, with the train itself. So, yung paa mo, na-applyan siya ng force, so tuloy na siyang mag-forward. Pero ikaw, dahil sa inertia, you have the tendency to stay at rest. So, pag walang in-apply na force sa'yo, parang maiiwan yung upper body mo, no? Kaya ganun yung nangyayari sa atin kapag nag-stop, tsaka kapag nagbiglang umaandar yung mga vehicle. Okay. So
yun pala yung nangyari sa akin, no?
Oh, yun yung nangyari sa iyo,
So,
sir.
kasi nung tumalon ako nung bus, the bus is moving to the right and I jump out. So, yung tendency ng body ko is to move to the right. Tama ba?
Okay, kasi parang i-continue mo yung previous state mo, which is in that direction or moving in that direction. Okay, yun. So, kaya, naging stuntman ka bigla. Okay, yun. So, ang nangyari. Okay? Ayan. So, sige, saan natin ginagamit pa yung knowledge natin dyan? So, of course, no, if ganun nga yung nangyayari na kapag nagkaroon ng sudden stop, your body, no, will tend to move forward. So, there may be instances na mangyayari ito. Okay, lalo na kapag yung kotse mo ay bukas, no? Okay, so wag tayong gumamit ng mga kotse na bukas na ganyan. Okay, buti hindi na uso masyado ngayon. Yan. So, yan ang mangyayari sa'yo kapag hindi ka ano ang sikreto para hindi yan mangyari sa'yo? That's why na-develop yung technology ng mga seatbelt. Tsaka lagi tayong pinapaalalahanan na please hold the handrails. Okay, pag nagpunta ka sa ibang bansa, paulit-ulit nila yung sinasabi, please hold the handrails, blah, 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 blah. Okay, lagi tayong pinapaalalahanan na please hold the handrails. Tsaka lagi tayong pinapaalalahanan na magsuot ng seatbelt. So, paano nila na-conceptualize yung idea ng seatbelt? So, because of this, no? Because you have the tendency, no, to continue moving even though your car has already stopped. No, kasi nga ang nakadikit lang sa kotse is yung yung puwet mo tsaka yung paa mo, no. So yung upper body mo is hindi. So especially if the stop is too sudden, okay, so if you are initially moving at a high speed, no, so syempre itutuloy mo yung motion na yun even though the car has already stopped. So ginagawa natin yung mga ganyang paalala, no, so safety procedures saka mga safety equipment so that you'll be part of the system. Okay? So kailangan mo humawak para maging part ka ng train or nung sasakyan. Kailangan mong magsuot ng seatbelt so that you'll be part of the system no car. Okay? So that when the car stops, you'll also stop. Okay, ayun. So that's for your safety. Okay, so yan ang application ng ating Newton's first law. Okay, next naman, anong ibig sabihin nung pag nakakita tayo ng ganitong road sign? Alam mo ba yan, sir? Do wala kaming sasakyan, no? So baka hindi namin to alam. Okay, so ang ibig sabihin niyan is, hindi niya alam. Okay, so parang sharp, parang warning siya no that there is no a sharp curve ahead. Okay, so makikita natin 'yan bago tayo makarating sa sharp curve no pag nagde-drive tayo. So bakit kailangan ng ganyang warning kapag may sharp curves? Kasi ang tendency no kapag kailangan kasi nating i-limit no yung speed natin when we have to be careful, no? And we regulate our speed whenever we make a turn sa mga sharp curves, no? Especially if it's too sharp. Okay. So, ang underlying principle dito is yung ating I will explain, I will relate it later. No? So let's us first discuss yung Newton's law of acceleration. So sinasabi sa Newton's law of acceleration, yung acceleration is directly proportional sa net force at saka inversely proportional sa mass. Therefore, in expression, we have, okay, yung mga pag tinanong mo yung mga bata no, kung anong alam nila equation sa physics, ito yung ano nila, ito lang yung alam nila actually. Okay, so F equals ma. Okay, because there are several forces acting on a body, no? Hindi lang isa. Okay, so yung equation na yan. So pag in-apply natin yan sa object na gumagalaw or that is moving in a circular path, just like kapag ka nag-ground ka ng curve, no? Or nag-turn around a curve ka, so ang makuha nating equation is FC. So ano may sabihin ng C sa ilalim? Centrifugal. Ang objects, they are kept in their objects moving in a circular path are kept no sa kanilang path by the centripetal force, no? So yung force na nagko-cause no kung bakit sila gumagalaw in a circular path is the centripetal force. So it's equal to, pag applied yung Newton's second law, pag in-apply siya sa circular motion, magiging Fc equals mv squared over r. So, hindi naman tayo magde-derive dito, no? Basta yung v squared over r is yan yung acceleration kasi kapag the object is moving in a circle. So, bali mass times acceleration din yan. So, for a car no that is moving or that is turning around the curve, ang nagsiserve as the centripetal force or ang nagpo-provide ng centripetal force dyan is the friction. Okay? The static friction between the tires and the road. Okay? Ayan. So, syempre yung friction, may limit yan, no? So nakadepend siya actually sa coefficient of friction kung natatandaan yung inyong mga lesson no sa friction and sa Newton's law. So nakadepende yan sa coefficient of friction. So yung coefficient of friction depende siya dun sa material nung nag-interact. So halimbawa, in this case, yung rubber tire tsaka yung concrete. So 'di ba pag mas rough, no, parang mas mataas yung friction. Okay. So yung speed with which you can turn around the curve, nakadepende na kayang i-provide no. So, since limited yung friction, limited din yung speed na pwede mong maging speed mo when you turn around the curve. That's why lagi tayong pinapalalahanan na to take caution, no? Kasi kung sa straight road kaya mong humarurot, no, sa pagka-sharp curve, so limited yung pwede mong itakbo, yung speed ng takbo mo ng kotse mo because it depends on the friction. And the friction cannot be too large, no? So sabihin, bakit di na lang pagaspangin yung road, no, para malaki yung friction. So syempre, we cannot do that because it will worn out the tires, no? So lagi ka namang mapaplatan yan or magiging mabilis yung lifespan ng tires mo. So anong solusyon doon? So in order no for it to be safer no to turn around the curve, ginagawa nila is binabank nila yung curve, okay, or yung road. So pag sinabing bank, parang ini-incline, okay? So kung nakadaan na kayo sa mga ganyang klaseng daanan, no? So mapapansin nyo hindi siya even, no? So that's an example of a banked curve, no, or a bank road. So ginagawa siya sa mga curve. So hindi naman siya ginagawa sa mga straight na daanan, no. Sa trip lang 'yun pagka ganon or nagkamali yung gumawa. So ginagawa siya kapag sa mga instead na friction yung nagpo-provide ng centripetal force, natutulungan siya no component ng normal force. Okay, so yung normal force is yung force na ine-exert ng nung ground pabalik dun sa kotse. 'Di ba yung normal force kapag nakatayo ka halimbawa. So meron kang gravity, tapos binabalance 'yun ng normal force exerted by the floor onto your feet, no, or onto your body kumbaga. Ayan. So yung normal force pagka naka-angle yung ating road, nagkakaroon siya ng component along the horizontal, yung nakatapat sa center, no? So instead na purong friction lang yung yung nagpo-provide ng centripetal force, nagkakaroon ng centripetal force coming from the component of the normal force. So, syempre, in this case, hindi na kailangan na sobrang laki ng friction kasi may tulong na from the component of the normal force. Okay, so pwedeng yan yung gawing solusyon no, para kahit na hindi natin pwedeng itaas masyado yung friction, pwede pa rin ikaw maging safe when you turn around a curve. So saan nyo ba makikita mostly yung mga ganyan? Di ba sa mga racing track, nakikita natin yung ganyan na no? Na itsura nung daanan or nung track. So hindi lang yan para cool, no? Para may thrill, okay, sa mga nagre-racing. So it's for them to be, kasi syempre ang goal mo sa racing, pabilisan talaga kayo, racing nga no? So pabilisan kayo. So para maging safe pa din sila, no, regardless kung itodo nila, iharurot nila yung mga kotse nila, is ginagawa yung racetrack is nakabank yung niya, no, yung road niya or yung surface niya, so that they could still be safe, no, kahit na bilisan nila yung pag-andar. Okay? Ayan. So pwede rin yang gawin kung alam mo na halimbawa yung road na yon is medyo slippery talaga or wet siya, no, lagi. Yung sa mga lugar na may snow siguro na laging nababasa yung mga road, ganyan. So pwedeng i-bank siya, no, so that the centripetal force will not entirely be provided by the friction, which can be limited, no. So nagbabago kasi yung friction pagka basa yung road, mababa yung friction. Kapag icy yung road dun sa mga lugar na may winter na nagsusnow, bababa yung friction. So bababa din yung parang pwede nilang itakbo na speed. So, para as a solution to that, so yung mga physicists, so they came up with this idea of banking the road, no? So, i-incline lang siya ng konti, kino-compute nila kung ilan dapat yung angle para makatulong yung component ng normal force sa pagpo-provide ng centripetal force, so that kahit medyo lakihan mo yung speed mo, hindi ka magsiskid, no, or maaalis dun sa circular path at tatalsik. Okay? That's physics for you. Okay? Yan. Sige. Ang next natin, syempre, fascinated tayo. Lahat naman tayo siguro nakakita na ng parang how astronauts look like when they are inside their space vehicle, no? So, parang nakikita natin nadidisorient sila, ganyan-ganyan. So, paano kaya sila gumagalaw, no, dun sa loob ng paano, pupunta sila doon, kukuha silang pagkain, no? Paano sila makakapunta doon? Naka-float sila. So, anong ginagawa nila? Sir, ano sa tingin mo, anong ginagawa nila? Sa base sa mga napapanood. Ang hirap na matanong ko, no? Ayan, ayan.
Actually,
or may na-experience ka bang ganyang, parang scenario?
Oo, kahapon. Kahapon lang nagpunta ako sa outer space, kaya na-experience ko yan.
Hindi, yung may nakita kang ganyan tanong, ganyan yung i-apply.
Mic mo nag-feedback. Okay, no? Hindi, joke lang yun, no? Of course, no? Ayan. Pero baka, no? Kahapon, yan. Tinanong niya kasi kung may experience daw ng ganun. Baka kahapon.
Hindi natin alam, no? Baka pumuslit pala siya sa outer space.
Ayan, no? Anyway, no? So actually, guys, no? Sa mga ECE na naka-tune in sa ating show ngayon. So, this one, guys, is actually lumabas sa ECE board exam. Ayan, no? So, sa mga gustong mag-prepare for the board exam as early as now. So, this is a question na lumabas sa boards dati. So, ang question doon, yun mismo yung tanong ni Ma'am Colino. Kunyari nasa outer space ka daw. Kunyari wala kang magawa at namasyal ka sa outer space, no? So, you're floating just like the astronauts that you can see on your screens. It happens because walang gravity, right? Or actually, na weightless sila. So, gumaganon-ganon sila. So, yung tanong doon sa EC board exam, how would you move, no, if that's the case? Ayan, no? So, paano ka daw gagalaw, no? Tanong sa ECE board exam. So, paano ka gagalaw kung naka-float ka na ganyan, no? So, syempre, may mga choices, no? So, isa sa mga ano kaya ang no ang answer doon, no, sa question na yon, no? So sige, baka alam ni Ma'am Colleen ang sagot.
Oo, kala ko sir agawan mo ko ng nang i-explain eh. Okay yan. So paano tayo gagalaw pag nasa mga ganyan tayo nasa outer space and we are floating and we want to go to a certain direction, we want to move forward. Okay, ang principle behind this is yung ating, syempre, nakadalawang law na tayo. So meron tayong pangatlong. Nandiyan din yung ating third law, no? So, law of interaction. So, ano yung sinasabi ng law of interaction? So, when one object exerts a force on a second object, so may dalawang object, no? So, si object 1 exerts a force on the second object gaganti siya. Okay? The second object exerts a force on the first that is equal, syempre, di siya papalamang, no? Equal in magnitude, but opposite in direction. Okay? So, yan yung ginagawa natin. Ma-apply natin yan sa outer space kung gusto natin mag-propel forward or go to a certain direction. So, ang gagawin natin is, Sige, sir, pakian. Ang gagawin natin is, halimbawa, kung nasa loob ka ng spaceship or ng spacecraft, so syempre, anong ginagawa natin? Parang itutulak mo yung sarili mo, no? So, hampasin mo yung, or itatap mo yung mga nasa gilid mo, objects na nasa gilid mo, para, so nag-exert ka ng backward force sa kanila, so itutulak ka nila. Parang ganun yung mangyayari. Kaya kapag yung mga astronauts, no, when they want to navigate or go around inside the space vehicle, so itatap lang nila, parang babanda sila, no, dun sa mga object na nandun. So they are exerting a backward force. So yung object, so yun nga, gaganti siya. No? So the object will also exert a force na equal, pero pa forward. So mangyayari, makaka-forward ka. So ngayon, applicable din siya kapag nasa labas ka na ng ng space craft mo, syempre. So halimbawa, nag-repair ka ng something or kumuha ka ng sample sa isang celestial object or astronomical object, asteroid or something. So tapos ka na. So babalik ka na sa iyong spacecraft. So, ang pwede mong gawin is, kung di mo na siya kailangan, okay, you can throw any object na hawak mo, no, in the opposite direction. So, halimbawa, pa-forward ka. Pwede mong iba to pa-back, no, yung iyong object na hawak. And then, the object, since pinush mo siya, it will push you back, no, in the opposite direction. In that case, makaka-forward ka, no? Makakapunta ka, makakabalik ka sa iyong spacecraft. Pero syempre, you have to consider the masses also, no? Kasi kailangan, medyo malaki din yung object na gagamitin natin dahil yun nga, no? So, pagka naman masyadong maliit yung force, no, I mean, dahil malaki yung mass mo, baka hindi ka mag-accelerate. Okay? Kasi nakadepende din yung acceleration din sa mass natin. No? So, dapat yung object na itatapon mo siguro is